Thank you for joining me. I will be explaining the charging phase of a camera circuit. We first start out here with the switch, and we flip the switch on, which completes the circuit, which runs along here. And charge flows this way towards the positive side of the battery and repels from the negative side. And what we have here is a capacitor, and the capacitor is composed of two plates, where one plate will build up negative charges and the other plate will build up positive charges. So essentially we have here is, on this plate here we have a whole bunch of negative charges building up, and when that happens, a lot of positive charges will build up on this side, which will influence the P on the transistor, and the negative charges here will influence the N on this part of the transistor. And when that happens, it opens, or it causes the transistor to turn on, and current can flow through here, or voltage. And we'll continue on to the secondary part of the circuit, which will come up here into the primary coil. In the primary coil, there is voltage pumping through it. So, as we know, a change in voltage will cause a change in current, which will cause a change in magnetic field. And when that happens, it influences the secondary coil and causes a change in voltage, which is a change in current, which is a change in magnetic field to oppose that change. And when that happens, we have essentially 1 volt passing through here and being converted into 300 volts that pass through here. This secondary coil will then essentially affect the feedback coil, which we all know that the change in voltage results in a change in current, which in turns results in the change of magnetic field to oppose that, and it changes the polarity of this feedback coil, which then fundamentally discharges this capacitor. Now, the thing about discharging the capacitor is now you don't have the charges built up on it, and if there's no charge built up on this capacitor, then this P portion isn't influenced and this N portion is not influenced. So the transistor turns off. So now, since that occurs, there is no current or no voltage passing through this circuit through the primary coil, which, as we know, no voltage compared to some voltage in change is still a change. So a change in voltage is a change in current, is a change in magnetic field, and it goes back through, and same thing here. The polarity just reverses, and essentially the polarity on the feedback coil will then revert to its original form, causing charges to start building up again on the capacitor. And when that happens, the transistor will turn back on, and the whole process will begin again. And this happens anywhere from 4,000 to 5,000 times, and so it's very quick. And that's for the first part. And as current passes through the secondary coil, we have the neon light, or the indicator light, here, and we have the capacitor for that, and so that's not really important. But anyways, the current will pass through here, and if you see here, it's hard, I have a shitty camera. Diode is a one-way check valve, basically, for electrical pressure. It allows current to pass in one direction, but not in the other. So essentially what we have here is an AC current, and as it passes through the diode, we have a direct current, which then comes up here to charge this main capacitor, which is 300 volt rating, or 330. I can't remember which one. And if we didn't have the diode, by the way, is the one-way check valve, then every single time this bottom portion turns on and off, would pull the charge that we are storing here in the main capacitor back out. So we'd be constantly putting in, taking out, putting in, taking out. And if we have, if we add $1 to our savings account, we take the $1 out, and we keep putting the $1 in and taking it out, we essentially have a net balance of 0, and that can work for voltage. And so that diode is very important in allowing us to put the $1 in, or the voltage, and keep saving up that voltage without taking out. And so when that happens, we have a switch down here, which is the shutter switch, or the shutter button. When that's connected, current passes from the capacitor through this switch into this coil right here, which then influences this coil, which then affects this trigger plate. And this right here is a tube of gases, and as we know, if we ionize a gas, we're increasing the collisions and exciting the electrons inside those atoms. And when an electron is excited to a higher energy state and then falls back down, it emits light, and that's what the flash is here. And that is the charging process of the circuit diagram. And okay, so the next part that we're going to discuss is firing of the BB. Here we have our main capacitor, which we take apart and we add another portion, another circuit onto here. Instead of using this switch, what we did was we hooked this up to our coil gun, and built a little switch for it to complete the circuit. So we have our energy source here, our voltage source, and when we hit our button, what happens is voltage passes through there, and we have here the coil, and we have a north and a south. We have a BB that is a north and a south. And what happens is when voltage passes through this coil, it causes a change in current, which causes a change in magnetic field. And what that causes is the northern part to repel the northern part of the BB, which causes the BB to accelerate towards the opposite side. And one of the greatest concepts of this device is for us to release all of our voltage or energy through the circuit before we get to the midpoint of our coil gun, because essentially what happens is we want that to keep accelerating, and so as it gets closer and closer to this midline here, once it passes through, we have the influence of the south portion on the south part of the BB, which is bad because we want our BB to move this way, not back that way, which we know same signs repel, different signs attract. And so if we want our BB to move this way, we don't want the south to repel the south of the BB back that way. So the fastest part, or the point at which our BB will be traveling the fastest at the time of all the energy being expended, would be the center point, and that would be a firing of the BB. So next part we need to discuss is components of a circuit, and one of them is a transformer. And what a transformer is a component that has two coils, and while voltage passes through one coil, it incurs a change in the electric field. And a change in electric field results in a change in the magnetic field, and a result causes a change in magnetic field of the other coil, and change in electric field of the second coil, resulting in voltage flow. So it's basically to amp up the voltage of the incoming current from one coil to the other. Just like in our camera circuits, how our primary coil had only like 1 volt, but it influenced the change in the secondary coil, which resulted in upping of 300 volts and charging our capacitor. And the next part we need to discuss is a diode. And like in our circuit, a diode is a device that acts like a one-way valve for circuits. It allows current to pass through one way and not the other. It's utilized in AC currents where the oscillating current would push charge and then in response pull charge. This allows only pushing of the charge in an AC circuit. So it's like in our camera experiment, how this allows the voltage to pass through, but due to the way it's built, it doesn't allow it to come back, and in result allows us to charge our main capacitor to 300 to 330 volts. And so that's basically a one-way valve. The next part is a capacitor, which stores energy. It has 2 plates which are separated by a strong insulator. The positive plate accumulates positive charge and the negative plate accumulates negative charge. And so essentially what it does is it doesn't conduct electricity. We have here the positive side, and then we have the negative side. And essentially negative charge builds up on this side and positive charge builds up on this side, but since we have a strong insulator in the middle, none of it passes through. And like in our camera experiment in the first phase, this allows us to influence a transistor. And as you can guess, our next component is a transistor. Okay, a transistor is a semiconductor device used to amplify and switch electronic signals and power. It's made of silicon doped materials. Regions between terminals are known as depletion zones. And so the most common one that we've learned about is NPN, which essentially the P would be doped with a different chemical than the N's. I can't remember exactly what the chemical or the elements were. I think it was gallium and arsenic. But anyways, that's what a transistor does. Like in our circuit, we have light. Light is a range of radiation that we call electromagnetic radiation. The source of all electromagnetic radiation is accelerating charge. All of the electromagnetic spectrum is created by the sun and various other sources naturally and man-made. The range of the spectrum starts at the lowest frequency, called radio waves. Then it goes to microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays, being the frequency with the most energy. One of the most common and used devices that man has used for creating microwaves is a microwave oven. And essentially what you do is you bombard the water molecules in food with microwaves, which cause the molecule to vibrate, which we know that temperature is vibrating atoms, and so it cooks your food. And that is what light is. And I'll be discussing reflection, refraction, dispersion, diffraction, polarization, and interference in the next segment.